Hello and welcome. In today's lesson, we will talk about one of the most famous math formulas, the quadratic formula. Remember that in the past few lessons, we have been trying to solve quadratic equations. Quadratic equations are equations of the form ax squared plus bx plus c equals 0. Our first attempt was to solve a quadratic equation by using the graphing method. And when we did that, we said that if we graphed the quadratic relation, which is in the shape of a parabola, not that one. So we said that the solutions to the quadratic equation are the x-intercepts, for the sole reason that the y-coordinate at the x-intercept was 0, and that's what the quadratic equation dictates we do. We make the coordinate y equal to 0. So the solutions are also called x-intercepts, are also called the roots of the quadratic equation. Our next attempt to solve the quadratic equation followed a different strategy and was called factoring. So the factoring method consisted on factoring the quadratic equation or writing the equation in factored form and then making each factor equal to 0. And by making each factor equal to 0, we were able to disclose the roots or the x values that made the whole equation equal to 0. So we solved that. Now, the question becomes, what if I have a quadratic equation that is too awkward to graph, okay, and it requires a lot of time and space? Or what if I have a quadratic equation that is impossible to factor? So how do I solve such equations? Well, that's the reason why we are learning the quadratic formula, and that's one of its greatest advantages. You can use the quadratic equation in any quadratic equation formula in any equation to solve any equation. So the most popular method of solving a quadratic equation is the quadratic formula. Sorry. It's very early in the morning. All right then. So to discover the quadratic formula, we are going to solve the equation ax squared plus bx plus c equals 0. So what we are going to do together is go through the process of how this formula was discovered. So we will think like mathematicians together, but I must emphasize here that you will never be asked, probably, I should say probably never be asked to derive the formula on your own. However, I believe that when we prove or when we go through the process of deriving the formulas that are readily given to us, because they were discovered by other brighter and greater minds, we tend to understand them better. We tend to be able to apply them better and appreciate them more in the meantime. So if you are not interested in following this process, by all means, skip ahead and just listen to the examples that I will go over in a bit. So here we go. We have to solve the equation ax squared plus bx plus c equals 0. And we are not going to give a value to the coefficients, so they will be kept literal coefficients so that we can disclose what the roots will be depending on any value of these coefficients. Remember that every quadratic equation can be written in all quadratic equations can be written in this form, and what makes each quadratic equation unique is the values of a, b, and c, okay? And that's a relationship we are trying to discover. So let's get to work. I'm going to rewrite the equation as is first. So we have ax squared plus bx plus c equals 0. Remember, we are solving an equation, which means that we have a few freedoms in here. We can take terms from one side to the other. We can multiply, divide, add, subtract to this equation. As long as we do the same thing to both sides of the equation, then we are fine, okay? So we're not changing the equation itself. So this is what I'm going to do in my first step. I'm going to try to isolate the variable x. So the variable x appears in two terms, first and second. So I will keep these two terms to the left side, and I'll take c to the other side. And the equation now will look like this. My next step is, because I want to get closer to x, I will divide by a every term in both sides of the equation. So my equation now would look like this. Sorry, that was a c, it looks like a 6. So the equation now becomes x squared plus b over ax equals negative c over a. And now I'm going to try to solve this equation by a method that is called completing the square method, which we don't go over in grade 10, but you will learn it in grade 11 for sure. To complete the square, we are going to look at the terms we have in the left side of the equation, and we'll treat these two terms as the first two terms of a perfect square trinomial. Remember how we completed the square. To complete the square, when we have the first two terms, we are going to take a look at or work with the coefficient of x. And we take the coefficient of x, which is b over a. We always divide by 2 and then square it. Okay? And that will be the third term. This will give us the third term we must add in here in order to make this binomial into a perfect square trinomial. So b over a divided by 2 is the same as if saying b over a multiplied by 1 over 2, and then we'll square it. Now b over a times 1 over 2 is b over 2a, and then you square it again. And even in more simplified form, this will turn into b squared over 4a squared. Remember that this power of 2 will apply to b, will apply to a, and number 2. Everything that's inside the bracket, so every part of the term. So here we go. We have found the missing term that will turn this binomial into a perfect square trinomial. So we'll add that term to the left side. So x squared plus b over ax, and then plus b squared over 4a squared. So now we know that the left side will be a perfect square trinomial. And now you're probably thinking that you added something in here, you changed the equation. Well, to maintain the balance, I'm going to add the same term to the other side of the equation as well. So plus b squared over 4a squared. So now I'm going to say that the equation is balanced and it's the same as it was before. Now, the next thing that we want to do is write this perfect square trinomial that is in the left side of the equation in factored form. And because I know that this is perfect square, I know what the factor form would look like. It will be a binomial squared. And the binomial is obtained by square rooting the first term, x squared, so that's x. And the sign will be the same as the sign of the middle term, so plus. And then the next term will be the square root of the last term, so b over 2a. So that would be here, b over 2a. And that is obviously squared. So if you square this expression, then you get this trinomial. And that would equal, so in here I have to do a little bit of work because I need to add or combine these two terms. And I notice that the denominators are not ready to work together, so I need to make the denominator same, which means a has to become a squared. I know I can do that by multiplying by a, this denominator at the bottom and at the top as well. And I have to multiply also by 4, And I will do that as well. So I will multiply by 4 both numerator and denominator. Now my equation, or I should say the right side of the equation now, has turned into negative 4ac, and that's negative 4ac over 4a squared, and then plus b squared over 4a squared. Okay, so now the denominators are the same, so I can combine the two terms that are on the right side of the equation. So, and I'm also going to reorder the terms. I prefer to write the positive term first and then the negative. So now we're at a point where we have to solve for x. So we're getting closer to it. X is inside the brackets and it has an exponent, so we have to unlock this exponent. And to do this, we have to take the square root of both sides of the equation. And square rooting both sides of the equation, right, would look like this. And there is one little detail that I need to add, and I want to explain something before I do so. Remember, when you have, or if you're told that x squared equals, for example, 4. This is a simple example. Now, what would x be? So what was x that after being squared gave 4? Some bright mind would say, well, it must have been 2, because 2 squared equals 4. But some other thinking minds would say, well, you can square negative 2 and still get 4, so there are two possibilities. X could have been either positive 2 or negative 2. And that is the reason why that when we solve this equation, which, by the way, we solve by square rooting both sides, we take both the positive and the negative root of 4. And that's what we're going to do in our example as well. So we're going to say that x, the left side of the equation, square rooted, would equal plus or minus the right side square rooted. And here we go. We have x plus b over 2a. We know that this is an index of 2, and when you square root a squared number, let's say when you square root 2 squared, your answer is 2, right? And the same thing in here, when you square root a binomial squared, the square root of it would be the binomial itself. And then we have here plus or minus. And here I'm going to do a little bit of work with this expression. I am going to assign the square root to numerator, a square root to numerator and denominator, so they will have each their own root, which is totally acceptable. Because imagine having, for example, the square root of 16 over 4, right? That can be square root 16 over square root of 4. Because look at it, if you do the root of 16 over 4, that's the root of 4, which is 2. If you do root of 16, that's 4. Root of 4 is 2, so the answer is still equal to 2. So you can split the root. And that will be over the square root of 4a squared. Or should I say the square root of 2a squared? It's the same thing, right? So I'm getting somewhere in there, obviously. And now what I'm going to do is I'm going to take b over 2a, that is on the left side of the equation, to the right side of the equation for the sole purpose of isolating x. And I'm saying here that b over 2a will go to the right side. And one thing I should remember, it will become a negative. And then we still have plus or minus the square root of b squared minus 4ac divided by, and since I'm here now, I am going to simplify the root because I have the square root of something squared. So that means that it will equal that something, so the 2a. And I'm very happy with what I got in here because I see that I got the same denominator, which means I can combine these two terms into one. And I will say that x is equal to a big fraction, 2a in the denominator, so negative b plus or minus square root of b squared minus 4ac. Okay? And there we go. We derived the quadratic formula. Now, again, we are going to talk a little bit about this just because it's fun to talk about it. Here we go. And I'm gonna actually point at some special parts of this formula. Number one is this expression inside the root. We have a special name for it. That special part, the expression inside the root is what we call a discriminant. I don't know exactly the story of naming a discriminant, but my understanding, oh, I spelled it wrong. Okay, now I think that my understanding of it is actually that this expression contains all the coefficients of the equation, and we know that the coefficients of an equation make an equation unique, so it discriminates one equation from the other. Okay, now how do we create the roots? How many solutions can a quadratic equation have? A quadratic equation can have a maximum of 2 solutions, and the way we get that, or the way we get the 2 solutions, is by one time adding the discriminant and one time subtracting it. So if I were to split or make this formula more specific, I would say x1 equals negative b plus the root of b squared minus 4ac over 2a, and x2 equals negative b minus the square root of b squared minus 4ac over 2a. Okay, so we're now going to move on to practicing this formula, which is a lot easier than deriving it. As always, I've written all the steps here together, but I prefer that I explain the steps as we work on our examples. Here we go. The first example. In the first example, we have negative 5x squared plus 8x minus 3. Your step 1, identify the coefficients. And we're going to say that in this case, we have a negative 5, b is 8, and c is negative 3. So next thing I want to do is write up the formula. And especially when you first learn the quadratic formula, it's better to write it as often as you can, and it will naturally stay in your head. So b squared minus 4ac over 2a. So negative b is 8, so negative 8 plus minus square root of 8 squared minus 4 times negative 5 times negative 3 divided by 2 times negative 5. Okay, and now we simplify. We have negative 8 plus or minus, so 8 squared is 64, and 4 times 5, 20, minus 3, negative 60, so 64 minus 60 divided by negative 10. Obviously, you can actually simplify this or evaluate it by using a calculator much more quickly. I always like to challenge myself a little. So negative 8 plus or minus, remember you have root of 4 there, right? Totally unnecessary to write it in case you're wondering, but negative 8 plus or minus 2 over negative 10. And now that I've simplified the formula to the best I can, and I can't simplify any longer, I'm going to say that I'm ready to state the roots. I'm going to say the first root is negative 8 plus 2 over negative 10, and the second root will be negative 8 minus 2 over negative 10. And I am going to evaluate them. Negative 8 plus 2 is negative 6. Negative 6 divided by negative 10 is positive 3 over 5, reduced to lowest terms possible. And x2 would equal negative 10 over negative 10, or 1. So these are the two solutions to the given equation. One here and one here. Okay, so moving on to our next example. We have 2x squared plus 5x plus 1. Again, by all means, try it on your own. Your very first step should always be taking all the terms to the other side. You want to have the equation in standard form in order to be able to identify the coefficients a, b, and c. In this case, it's already in standard form, so we'll start by identifying the coefficients, which are 2, 5, and 1. Write out the formula. Okay. Negative b plus minus square root b squared minus 4ac over 2a. Substitute. So negative 5 plus or minus the square root of 5 squared minus 4 times 2 times 1 divided by 2 times 2. So that's negative 5 plus or minus. We have 25 minus 8, so that makes it root 17 over 4. So I want to stop here for a second. We cannot find the root of 17, so we leave it in this form because we want to express the roots in exact form. Now, if you were to solve this previous equation by factoring, you would have been able to, because the roots are rational and a fraction and an integer, a natural number to be more specific. In here, you wouldn't be able to factor it, but thanks to quadratic formula, we're able to identify or find the values of the roots. So we're going to say that x1 equals negative 5 plus root 17 over 4, and x2 is negative 5 minus root 17 over 4. And I'm going to box the roots just very quickly here. And we're moving on to our next example. The next example, we want to make sure all the terms are to one side, are brought to one side of the equation. And we have 4x squared minus 12x and then plus 9 equals 0. The coefficients are 4, negative 12, and 9. So the roots will be negative b, the formula first, plus minus square root b squared minus 4ac over 2a. And then we have to substitute. And we have negative 12, positive 12, plus or minus square root. Let me make this straighter. So 12 squared minus 4 times 9. And then over 2 times 4. And let's see what we get in here. That's 12 plus or minus. So we have 12 squared, which is 144. Minus 4 times 4, 16. 16 times 9. That's 144 too. Huh? That's interesting. Let's see what we're going to get in here. This example is turning out to be quite an interesting one now. So we have 12 plus minus root of 0 over 8. Whoa. So that's 12 plus or minus 0, but do I really need to add and subtract a 0? Not really. And if you reduce this to lowest terms possible, we're going to get 3 over 2. So in this case, we're going to say that x1 or x2, it doesn't really matter what we say, are 3 over 2, both of them. And I'm going to stop for a second here, and I'm going to talk about something with you. Now, remember in the first two examples how we got 2 roots? We call them 2 real roots. And because they're different from one another, we call them 2 real distinct roots. So I'll write that down. 2 real and distinct roots. Okay, and the same thing happened in the next question. So we had two real distinct roots, but they're not like fractions, like easy fractions. They are like, they have a radical sign in here, so they're kind of irrational, we call them. But this would be sufficient enough. Okay, in the next example we only got one root, and some people may say that it's reasonable to say, well, we get only one root, and that's totally fine. To be more specific though, we're going to say that here we get not one but two. They're both real, but they're equal roots. Why do we say that they are equal to real equal roots? If you were to graph this function, you would have had, or we would have seen in here, let me make this. So if we were to graph it, we would have seen this parabola intersect the axis only at one point. And this equation would have been factored in the form 2x minus 3 squared equals 0, right? So we would have had two factors, 2x minus 3 times 2x minus 3, which means either x equals 3 over 2 or x equals 3 over 2. So x equals 3 over 2 twice, kind of. And that's where the term two real equal roots has the roots from, or has come from, okay? So we're moving on to our next example. Let's see if this one brings any surprises. X squared plus 4x plus 7 equals 0. So we have the values of a, 1, b, 4, c, 7. I'm going to say that x equals, I'm not going to write quadratic formula here, negative b, so negative 4, plus or minus square root of b squared, 4 squared, minus 4 times 1 times 7, divided by 2 times 1. And that's how you're going to solve quadratic equation this fast, right? So once you memorize the formula really well, and you have negative 4 plus or minus 4 squared is 16 minus 28. Well, 16 minus 28 is negative 12. So it seems that we have to square root a negative number in here, and we know we cannot square root a negative number. So we're going to say in this case no solutions. Okay, and to be more precise, actually we're going to write no real roots or solutions, right? That means the same thing. Now, why do we say no real roots? Are there roots that are unreal? Well, as a matter of fact, there are unreal roots. We call them imaginary roots, but that's something you look into in grade 11 math course, okay? Now, I'm very curious, and I want to see what is happening with the graph of this equation here. Okay, what does it look like when the graph has no roots? So I'm going to graph this x squared plus 4x plus 7 on decimals. So x squared plus 4x plus 7. And let's see what happens. So when an equation has no roots, a quadratic equation has no roots, that is because the quadratic equation has no x-intercepts. So it opens up and then it is above the x-axis. Now, from the algebraic point of view, what made this equation have no roots? We're going to say that an equation, or this equation, had no roots due to the fact that this equation had a discriminant that was negative in value. Okay? And we're going to make a point in here. We're going to say this one here. Oops. Okay. So no roots, no x-intercepts, and that's because the discriminant, which is b squared minus 4ac, was negative. And similar to this, we're going to say for this example, it had only two real equal roots because b squared minus 4ac here was equal to 0. Okay. We have two last examples that we want to talk about. By all means, you stop the video and continue doing this on your own because you have all the tools to solve these equations. If you want to listen to the solutions, let's keep going. So here we have, with this very interesting equation, bunch of terms on both sides of it. Actually, I should say three sides of it because I made a typo. I'm going to fix it right now. Sorry about that. Here we go. So I'm going to make this. I'm going to erase this. Forgot to delete it. Alright, so here we go. We have x squared minus 31 minus 2x equals negative 6 minus 3x squared minus 2x. We must take all the terms to one side of the equation, and that's because, here we go, we need all the equation to be in standard form. So we have x squared on the right side, negative 3x squared will join, so plus 3x squared. And then we have the term negative 2x in the left side, and the other negative 2x will join, right, because it's on the other side. And then we have negative 31 in the left, and positive 6 will join as well. So we got 4x squared here, minus 2x plus 2x, 0x, and negative 31 plus 6 would equal 25 negatives. And yes, we can use the quadratic formula here. We can use factoring very easily. But I want to show you something different, actually, that we have not mentioned before. Since here we have only one x term that appears in one of the terms, right? Then we are going to isolate that term right away, and we're going to write it as 4x squared equals, and take negative 25 to the other side, becomes 25. The next thing you want to do is square root both sides. And we already know that if we square root both sides of an equation, we shouldn't forget the plus and the minus before the number, right? And then we're going to go ahead and square root the left side, which is 2x, square root the right side, which is plus or minus 5. So we're going to say that x equals plus or minus 5 divided by 2. If we want to split the solutions here, so our answer is clearer, then we're going to say it's either 5 over 2 or negative 5 over 2. That's it. The next equation is kind of unique too. It doesn't really need us to apply the quadratic equation. Well, we can, but that is going to be a lot of work in the left side to expand and bring to standard form. But I do see that I am readily given the binomial to the power of 2, and the other side is just a 24. So I'm going to there and square root both sides of this equation. And I shouldn't forget the plus and the minus before 24 there. And we'll have x plus 3 equals plus or minus root of 24. So to isolate x, you just take 3 to the other side, plus or minus, and now I'm going to play a little bit with number 24. I'm going to write it a bit differently as 4 times 6. And the reason why I want to do this is because I can square root 4 and square root 6 separately, and that will give me a more simplified answer, 2 root 3. Do not worry about how we simplify the radical numbers. I don't think it's something that you've learned in this course. You will look into it in grade 11. For now, we're just going to state the roots, negative 3 plus 2 root 3, or negative 3 minus 2 root of 3. And this is it. This is today's lesson on solving quadratic equations by using the quadratic formula. And actually, we looked at some more examples as well. I hope you enjoyed the lesson, and I hope this all made sense. And you have some practice questions if you want to continue practicing as well. Bye for now.